Take the daily workflow of a small business owner like Mira. She starts her day with a digital assistant that has already sorted her overnight emails, highlighting refund requests and sales leads. Later, her accounting software flags an unusual payment pattern, and a marketing tool suggests which customers might respond to a discount. These systems work quietly in the background, recognizing patterns and providing insights for human review. Artificial intelligence is moving into active execution. Software is now triggering events and taking independent action, shifting away from being a passive assistant. This capability is known as agentic AI. These systems pursue goals, navigate software, and complete multi-step tasks without a human prompting every individual step. Organizations are deploying software that performs the work directly, executing tasks that previously required a person to read a suggestion and click a button. Systems that can act independently create new operational risks. To manage them safely, we have to look back at the mechanics of how we taught machines to process information in the first place. This timeline of AI milestones shows the field's formal start in the 1950s. At that time, researchers relied on symbolic AI, where every behavior was dictated by thousands of human-written if-then rules. These rule-based systems were predictable but fragile. They broke when encountering unprogrammed scenarios. The shift to machine learning changed this. Instead of writing every rule, engineers fed massive datasets into neural networks, allowing machines to identify statistical patterns. By the 2000s, this pattern matching enabled computers to recognize faces in photos and translate languages, and flag credit card fraud by comparing new transactions against millions of historical examples. Neural networks gave AI the ability to predict outcomes and classify data. However, the technology remained analytical. It could interpret existing information, but it couldn't create anything original. In 2017, the introduction of the transformer architecture changed the objective. It allowed AI to process the context of information at a massive scale, turning categorization tools into generative ones. This enabled software to generate original text, functional computer code, and realistic media from simple prompts. Today, we are adding autonomy to that generative power. This is the shift to agentic AI. An agent breaks a complex goal into smaller subtasks, selects the necessary software tools, and sequences them to complete a job. In a customer support workflow, an AI agent reads a ticket, searches internal policies, drafts a response, and routes the case for approval. It manages the entire process. A system that can execute multi-step workflows across different applications functions as an autonomous digital worker. Because machines can now make plans rather than just take orders, the human role is changing from programmer to supervisor. The risks of autonomy are significant. While an error in a chatbot produces a bad paragraph, an error in an agent can lead to deleted databases or unauthorized financial transactions. Without oversight, a small mistake compounds instantly. This makes human-in-the-loop governance mandatory. It places a checkpoint in the automated workflow, requiring a person to Xanavive agent's logic before it can proceed. Effective governance involves setting strict boundaries. Humans define the agent's scope, limit its system permissions, and approve any high-impact actions. AI is a human-made capability. Its long-term value depends on how wisely we choose to govern, limit, and direct its autonomy.